Hey everybody, thanks for joining us today. My name is Jim Armstrong. I'm with Snyk on the product side. I've been with Snyk for a few months now. Previously, it was at Docker. I'm really excited about today's live event and the speakers that we have. We have a couple of Docker captains who I've known for a couple years now, and they're absolutely fantastic. A wealth of knowledge, great presenters. I think everybody's going to really enjoy today's session. And so I'm really looking forward to learning a lot. I hope all of you are as well. We have essentially two sessions that we're going to do today. We'll have a short break in between so everybody can get some snacks and take a bio break. But we're going to start out with a focus on container security. We have Brett Fisher and Nigel Poulton here. They're both going to be here for both sessions, but Brett's going to kind of lead this first session. If you don't know Brett, I don't know where you've been. If you don't know Nigel, I don't know where you've been either, but they're great people to know and follow. Brett's a Docker captain and a general DevOps dude. He runs a live show weekly that is very informative. Tons of great guest speakers that come on that show. He has courses on Udemy, and there's a link here to get to his courses. They're very inexpensive, but extremely informative. And he's done workshops at DockerCon. He's done trainings for organizations and all kinds of things. So fantastic resource here. So we're going to start with that. The second session will be led by Nigel, and Nigel is also a Docker captain. He's written two fantastic books on Docker and Kubernetes. He's a Kubernetes trainer, and his courses are on Pluralsight and acloud.guru. He's, through his books and videos, has trained over 1 million people. So a fantastic resource there as well. And so we're really looking forward to that. Today's sessions are meant to be very interactive, so feel free to ask questions. There's a Q&A box that you should have access to, and you can type in your questions there. We're going to make this as interactive as we can, so we'll be answering questions as we go. Brett, I should say, and Nigel, I'm just a pretty face, I guess. And then in the chat window, we also have some links to external resources for you. So there's some from Brett and from Nigel and some from us at Snyk as well. So some great resources for you to use sort of after the presentation too. A real quick intro to Snyk for those who are not familiar with what we do as an organization. So we are a very developer focused company. So we focus on helping developers use open source to build their applications in a secure fashion and use containers to ship those applications and make sure that all of those are secure. We help you find and fix vulnerabilities there. We help you with license compliance. And really the focus is on helping you fix those things. So without, a deep security background, being able to address the issues that you find in your containers, in your Kubernetes configurations, and in your applications, and be able to fix those. Question that comes up all the time, is it Snyk? Is it Snyk? Is it Snyk? What is it? And the correct answer, as you probably heard me say, is Snyk. There are a couple of Brits who say Snyk, but just ignore them if you hear them somewhere else. Without further ado, I'm going to start to hand things over to Brett here. I do want to put a quick shout out that pretty much everybody that's on the presentation here today will be at DockerCon next week as well. So Brett and Nigel will be on the Captains on Deck channel. I've got a presentation there as well, so hopefully you'll come see me again. And Gareth Rushgrove, if you know Gareth, he's our product director and also was at Docker with me for a couple of years, and he'll be doing a presentation there too. So that's my spiel. Brett, you ready to take it away?
Let's do it.
All right.
All right. Cool. Hello, everybody. I'm Brett. I do container stuff on the internet, usually on YouTube, but all over the place. So I've like he was saying, we don't need to talk about me. I just been doing this forever. I've basically 5-6 years been talking about Docker nonstop. So let's keep with that trend. And I love talking about security topics, especially for people that are maybe not full-time security people like myself. I've always been sort of that sysadmin ops role with a little bit of dev and a little bit of security and a little bit of networking. And so I would always go get a couple of those certificates and certifications to sort of know what I'm talking about a little bit, but I spend most of my time managing servers, managing deployments, helping developers Dockerize their apps. And there's a lot that I've learned from that. So this URL here, it will be shared, but this is basically a subset and some demos around the things that I talk about in this URL, which takes you over to a long and expanding list on really just a GitHub issue. I run an AMA on GitHub for random container topics, and this list continually goes and goes, and we could spend all day on it. But there's some really important stuff in here, and I sort of want to focus on the things that are the best bang for the buck in terms of your containers, your Docker hosts. How do you lock those down? How do you enable all the default security features out of the box? How do you help your applications be more secure in containers, not just with scanning, obviously, with all these scanning tools that we have now. That, Snyk's great, so we can use that, but there's lots of other things we can look at in terms of the full pipeline of getting our apps from the developers all the way onto the servers. And let's talk about some of that. So first up, now the rule here, if you've ever been on my live shows or anything else I've done, is I'm here for you. So let's do some Q&A, right? So as I'm talking, give me the questions that you have around the topic, and then I will stop after each slide, and we will take questions and talk about all the things that you want to dive into on that. We've built in tons of time for your questions, so it's really important that we get those answered. I'm sure you came here today with ideas and thoughts about things you don't know in security. So even if it's not directly related to the topic on the screen, please ask them, and we'll make time for them. Even if we don't know, we'll just have to tell you we don't know the answer to that. So the first thing up here is, let's focus a little bit on the engine. So when you start talking about Docker security and Kubernetes security, container security, there's different parts of the pipeline and different parts of your stack. And one of those things is the Docker daemon on your host, right? So whether it's Kubernetes running on top of Docker, or Docker running alone, or maybe you're running Docker Swarm, or maybe you're running Docker Compose on Docker, all those things have Docker daemon, or the engine, as the runtime down there at the bottom of the stack. And so that thing, once you've got it installed, has some security features that may or may not be enabled out of the box. So let's make sure that that stuff is checked off the list. The first thing there is just to do Docker, just to use Docker as your runtime. So let's talk about what exactly that does for you. If you're someone who's moving to containers and you're interested in exactly what you get out of the box with containers, then using the Docker engine does give you a bunch of advantages over maybe just running your apps traditionally. In case you're used to this, and we were all used to this, 5 or 6 years ago, we were used to running apps on VMs or physical hosts. Even if we were doing them in VMs, we were sometimes just running a single app in that VM and a bunch of different VMs and all that stuff. But that usually gave your application way more capabilities than it needed to have. So just by putting it in a container and running it in something like Docker Engine, you get a lot of these things out of the box. The first one is a container itself basically means it's running a reduced set of Linux capabilities. So the container engine, whether that's Docker or Containerd or Cryo or Podman or whatever, they typically will help reduce the potential access that your app has, whether your app's running as root or running as a regular user. Hopefully it's running as a regular user. When it's running as that user, it will get reduced capabilities inside that container. So out of the box, Docker reduces the number of Linux capabilities and syscalls that your app has access to. And that's a win, right? You just get that out of the box just by choosing to run in a container. So taking an old app that's pre-container, Dockerizing it in a Docker file, putting it in a container, boom, you already get that advantage in security and that reduced risk. The next thing is, if you're running on something like Ubuntu, which has AppArmor enabled by default, then Docker enables AppArmor by default. Now, AppArmor and a couple other ones here we'll talk about are an additional layer of application security where it will prevent additional access that maybe is unnecessary by your app. So the nice thing is that the Docker team years ago, I think 4 or 5 years ago, they went through AppArmor, SE Linux, and syscomp, and they or seccomp rather, sorry, seccomp, and they went through and they went through a bunch of the different open source tools out there, and they basically scanned them all to figure out what things they needed out of the Linux kernel just to just to figure out what things do they really need. Like, do 90% of apps only use 50% of the Linux system calls? Do we really need to give every application a full access to the system and the Linux kernel? And so they basically came up with some defaults that were sort of a default baseline, a good way to start without really breaking most apps, but also reducing the security risk of these apps running in containers. So one of the things that Docker does out of the box is it will just enable this AppArmor profile if you have AppArmor running. And you can find that on, for example, on an Ubuntu host under etc AppArmord. There's a Docker file in there, and you can see that profile, and you can enable it. It's already enabled technically if you have AppArmor running. On Debian, you have to run AppArmor. You have to set up AppArmor on something like Debian because it's not enabled. But once you do, then the Docker profile will show up there. Also with SE Linux, which is more something on the Red Hat side of things, it's very comparable to AppArmor. They both have similar functionality. You need to enable that in the Docker daemon config, and you would simply do that with an SE Linux option. You would add that to basically to the daemon startup inside of Docker. And so that would allow it to use its default profile, which Docker adds a Docker profile to your system by default inside of those OSs. And then seccomp, something in addition to those that's also very similar in the way that they all handle, things like system calls and capabilities in the Linux kernel. Seccomp is also enabled by default on systems that support it, which I think is nowadays all really just all of them. All Linux modern OSs have this. And the way that you can kind of see all this stuff is pretty easy. Obviously, each one has its own settings, and each one has its own pros and cons, and as you dig into the technicals of it. But if you're on a host, and I'm just on a standard Ubuntu machine I made basically an hour ago, and if you just do a Docker info, you can see there that the security options that are enabled on that system and that Docker's using are showing up right in that info screen. So if you're on a system like Debian, it won't show the AppArmor, but it will show the seccomp. If you're on an SE Linux enabled machine, it will list SE Linux there. Typically, you don't want to use both AppArmor and SE Linux, and I'm not pretending to be an expert in those. I just know that they're both very similar in their functionality, and you usually want to enable one or the other so that they don't step on each other's toes. So I just know that when I'm running CentOS, it's all about SE Linux. And then when I'm on Ubuntu, it's AppArmor. And out of the box, it's using those default profiles. Now, in my document over there on GitHub, you can see a bunch of references to the different default profiles. And if you're interested, you can technically take those defaults. If you get super advanced later on, you can make custom ones that are even more locked down for your applications. Most people don't go to that level because it is a lot of work, but there is some documentation on the process for that, and I actually put that way down at the bottom here at this list under number 11 for the custom setup, right? So you can go through Linux capabilities and do some really custom stuff there. And then when you run your container, you set those things as the profiles to use for that specific container, which means this stuff is all very container specific, which is great. If you have Nginx, for example, it might need a far fewer capabilities than something like an advanced Python app or some sort of Java application, right? So those would be different, and you could customize those. But the defaults are pretty great because, again, if you were coming from the pre-container world, you probably weren't doing all this stuff to begin with because it was really complicated and hard to get right. And now Docker has given us these default profiles that are kind of a best practice, or at least a good place to start. So let's stop for questions real quick. Just make sure we have, if there's any questions here on this topic.
There's a couple. One directly related to that is, do you recommend having SE Linux and seccomp enabled at all times?
So seccomp is enabled, at least in everything that I'm using. So for example, this is a Ubuntu machine, right? And we talked about that on Ubuntu, AppArmor is already there. It's already, seccomp is already there, so they're working. If I jump over to a CentOS 7.6 machine and I do the same Docker info, we'll see that by default, it's not enabled for SE Linux, but that's because I have to tell Docker to use that on startup. So I think the answer is yes, but. So if you're on a CentOS, right, go in and try changing the Docker daemon, and you can basically just Google these or look at my references in the GitHub link. And those we'll give you the guide on the steps you need to take for each OS. With CentOS, it's a little bit more of a setup process. You have to change the Docker daemon startup, and you need to specify that specific default profile. But I always recommend teams enable them for their servers, and then if they have problems, you can back off of those settings when you run specific containers. It's a little different for SE Linux because sometimes SE Linux can also step on your toes a little bit, especially with volumes and other things. But this stuff is not new, right? We've been doing this stuff in containers now 5, 6, 7 years. So if you have issues, it'll usually be with maybe databases or something that needs more access to the host, maybe, especially something that's maybe needing a little more of the capabilities of the OS. Maybe something like Elasticsearch might have some of those issues where it needs custom capability setups. And so you'll find tons of people talking about this, showing examples of how to allow you to run that app with expanded capabilities without giving it complete root, ideally, right? You don't want to have to give it everything. And yet your other applications can still be locked down. So I tend to leave the defaults, especially because I'm more of an Ubuntu fan, because I find it to be just easier and it works better with just everything. But maybe you're in a situation where you're required to use something like CentOS or Red Hat Enterprise Linux. So go check out SE Linux on that side, enable it in Docker, and then try your applications. You're going to know pretty quickly if your applications work or not. If it's a web app, either the app will work or not. If it's a database, either the database will work or not. It's usually a very black or white situation with these, because if they don't work, you will see a bunch of stuff in your seccomp logs or your AppArmor logs, your SE Linux logs. You will see a bunch of stuff in there saying that it's prevented things from happening, and it'll be pretty clear that, oh, that's the app I'm trying to run in Docker, and then you can sort of figure out how to loosen that up. So great question.
Yeah. Another good one here. This one, and great answer too. Thanks. Another question. This was a little kind of broader, I think, but it's still a really good question, and it's kind of more to the point of, I think, as you get started with containerization and you want to consider how you're going to get an app into a container, how do you sort of plan for that? How do you plan for an application to run in a container with security in mind from the start?
Right. That's a great question. I'd say that there's a general process, right? And we're going to touch on this a little bit later, because I'm going to talk about multi-stage Docker files and base image selection, stuff like that. But typically you just, step one, get your app to even run in a container. And so typically when I work with teams in consulting, if they don't have anything in Docker yet, we're just working with their app on their local machine, making a Docker file and just trying to get it to run. And that sometimes can be a little bit of a process. It doesn't usually require source code changes. We're just usually changing environment variables and stuff like that that's environment specific, right? And so we're getting that, maybe we do some memory tweaking if it's an old Java app, because we have to set up Java to handle the memory limits inside of Docker, in case because you're going to want to limit your resources. That's one of the advantages of containers, is you can limit resources as well. But you're going to, step one, get that thing to work. And then you're usually going to build a compose file to make the different parts of your app in different Docker files all work together. So Docker Compose YAML is really easy to use. It's a small subset of the functionality you get with Kubernetes. So it's easier to start with, at least to just get it running locally. So that means if your app is running with a database, you can make sure that the database is in a container, and then the app is running in a separate container, and they're able to talk to each other. And once you get all the parts of your app there, then you usually say, okay, now let's try to get it running on a server in Docker, and then maybe even eventually, let's try to, if you're going to do something like Kubernetes, you're going to say, let's try to get it running in Kubernetes later. But part of that process is eventually you'll care about things like the size of your image, the dependencies in the image. Let's minify this thing for production so that only the necessary dependencies are there. And I will get to that answer in a little bit when we get to that slide.
Yeah, a couple of things I would add there too. There's a lot of people and process involved in this. And I think, as you start to adopt containers and start to put your applications into containers, if you don't have a DevOps team or a DevOps-like methodology, it's a great time to start thinking about it, because the people that ultimately are running the platforms, whether that's Kubernetes or something else, will need to know just as much about the container security as the developers do. And to things like you just talked about, like if you've got AppArmor and SE Linux and all these other things, right? Everybody across the board is going to be responsible for getting that thing running in whatever production system you use. I mean, it could be functions, it could be ECS. It could be, there's all kinds of container services you could use. It could be OpenShift as a platform. It doesn't really make a difference. Everybody, that's involved in that is going to need to know what's happening along the way and be, in in high communications with each other. The testing along the way should be automated. There's lots of steps that kind of come into that too. So
Yeah.
Another good one here too, before we go on, if we use OpenShift on Azure or PKS on Azure, or, generally speaking, I think you could think of any kind of service, we mostly don't have access to our node cluster. So they don't have direct access to the actual underlying nodes themselves to look at AppArmor and SE Linux and those kinds of things.
Right.
What are your suggestions for those scenarios?
Yeah. So if someone else is managing your nodes for you, you're largely outsourcing that work, right? So then that's more of a conversation with that provider to say, hey, can you provide us information on exactly how you're hardening the Docker daemon? Are you enabling all these features? And if you have a lot of these places, though, you actually have the nodes. Like if they're like, for example, I'm not sure on exactly on OpenShift on Azure or PKS on Azure. But if you have access to the nodes, usually those places are just providing you the Kubernetes API, and you are creating the nodes yourself. And if that's the case, then you can run these things on the nodes and look at these things. Now, Nigel might talk about this later in the day, but the settings that you run in Docker are not necessarily the same settings as you run in Kubernetes. So just because you're using Docker, sometimes you will find that Kubernetes might disable these profiles. So you'll need to look that stuff up and make sure that those things are enabled. So this kind of leads me to the next topic, which I'm just going to jump to. And then if we didn't get to any other questions, we can talk about that next. By the way, for those of you that might ask, still, I think there was some information that came out at the end of 2019 at KubeCon that's still on a majority of hosts, 70, 80% of machines, whether it's running just a standard container engine or Kubernetes or something else, they're all still running Docker daemon underneath, right? So we've got these other options like Cryo, Podman, Containerd, but majority of people are still electing to do Docker D. Part of that is because it still has a superset of functionality. There still are a few edge cases. Also, it's because it's what people are used to. It's kind of the thing that they've been using for years before they maybe did orchestration. So you might need to compare that to others. And I'm not really an expert on telling you every single security feature on every single runtime and how they're all different. So that's really there are existing spreadsheets out there that you could probably find on Google that have varying levels of information on that. But I wanted to point you to the Docker Bench. So Docker Bench is this essentially it's a CIS scanner that allows you to go through sort of the best possible setup analysis of your engine on the server. So it's essentially like a scanning tool. It doesn't look necessarily for vulnerabilities. It's not a vulnerability scanner like Snyk might provide. It's more of did you install and configure Docker correctly, and are the things you're running in Docker on this machine using the best practice standards as designed by the Center for Internet Security, right? So this is an open source repo that we can go and we can run on any system that you can run a container on. Now, technically, we're going to run it here in a second. You'll see what it looks like. But it can run on anything that has Docker running on it, and but you do have to be able to have elevated privileges. So if you're in a hosted environment where you're only allowed to run containers and you're not allowed to run them in privileged mode. Privileged mode in containers for Docker basically means you're acting as if you have full system rights. You have sort of the true root of the system, and you really only want to do that for system level utilities or admin like utilities that you'd run on occasion. So if we went over here, we could check out the Docker Bench URL here. It's just under Docker/Docker Bench Security. And this repo has been around a long time, for years. And you can see some example output here, basically. But if you just scroll down, they give you an example of how to just run it inside of a Docker container. So you could run it directly on the host, but we're running Docker here, so let's just run it as a container. And you can see that it's going to bind mount a whole bunch of system stuff. It's basically giving it complete root access to the machine because it needs to do that to scan all of the namespaces, C group stuff, the capabilities that are running. So we're going to run that on a system that I just built and see what it tells us. Now, like any typical security scanner, you're going to get a bunch of different colors and a bunch of different warnings and things that are good, things that are bad. And I've never seen any of these run where everything was green, right? The info ones essentially are telling you things that are neither good nor bad. It's just giving you some info about your system. The pass ones obviously are ones that it recommends a certain setting and you have that set. And then the warn ones are ones that it recommended a different setting than what you have. I rarely have a true system ready for production that doesn't have any warnings. And just like any security scanner, you always have to take this in context and look at the things that it's actually warning on and decide if that's applicable for you. You might have to do some research on exactly what that is. When you are looking at that stuff inside of their repo, you can actually go up to the tests and look underneath all these shell scripts. And you can look at each one of the tests. For example, let's look under here. And so each one of these checks matches, right? So this is 1.1.2, and then I could go up here and look for 1.1.2, which it does not have here for some reason. So I would need to correlate those up, and so if I'm looking at the warning here, hopefully I can go find the 1.5 somewhere in this list. Actually, I might have to back up. 1.2.2. Anyway, you get the point. It's a long file. Let's see, 1.2.12. So then I need to go and figure out how to find the 1.5, right? So ensure auditing is configured for the Docker daemon. Ensure auditing is configured for all these different files. So ensuring, basically this is all auditing stuff at the host level. I'm more of a Docker guy, not so much the host level expert here. So I'm going to focus on user namespace support, which we're going to talk about in a little bit, but because that's a big one, and I love to talk about user namespaces. Centralized and remote logging is configured. So this one right here, I might have to go check out on 2.12, and that one is really about making sure that, for example, that all my logs are pulled off the machine, because if the machine is ever compromised, technically someone could always augment the logs on the machine. So I really want to get those somewhere else where they're trusted. This is kind of typical security stuff, but some of this stuff is very focused on Docker, like this user namespace support and the default C group usage and all that stuff. Anyway, didn't mean to dive too much into that because we don't have time for all that, but you'll notice that there's some new stuff down here that will even get into specific images and things like ensuring health checks are in your images so that when you're running your apps in production, Docker knows whether or not they're healthy. Also something you can do in Kubernetes. So this is relatively new stuff that they've added over the years. And if you find something and you're a security person and you think that it should be added in this, they do take PRs, right? This is an open source repo. So go back up to the top, look at the issues, and you could potentially submit a PR to them and see if you could add it to the list. But all this stuff is based on the CIS standards. So you can scroll here on their website, go over and read the PDFs on the CIS website. And they have this for Docker as well as Kubernetes and other container tools. So you can go look at that and dive into the benchmark itself and what it really means. It will probably have better documentation on this stuff than the actual source code, which, as you discovered, I couldn't even find. So that might be a better look. Let's see, do we have any good questions on that?
There's one, it probably relates more to the previous section, but I saw container runtimes in the Docker benchmark. So there was one that was there before, and I don't know if you have an opinion on this. If not, that's cool too. But, and I'm kind of paraphrasing, does the OCI container runtime, do all the other OCI container runtimes come with similar security profiles that you know of? Like the specific question here is like Podman and others, right? Do they?
Yeah. Well, so the first answer I think is I really don't know. I haven't actually looked. In terms of clearing up the other runtimes, so what I normally see in the wild, Podman is really not so much a server production tool. To me, it's meant for example, Podman is not for orchestration. It's really just for running a single server. And it allows you to use systemd to run containers without needing Docker or containerd, right? It doesn't run its own daemon. It runs as basically just spins up systemd stuff. So to me, Podman is more of an admin utility for running on your local machine in case you're a Linux person. I know you can technically run it on a server in production, but I don't really see that really being, I have not seen anyone that I've been working with doing that. So I haven't had to worry about security concerns on it because it was not really a production security concern. The thing with Docker and containerd, so when you think of order of the majority of people using it, most people still use Dockerd, and then the next biggest chunk of people are using containerd. And then the small chunk, there's a couple of percentage points I think that are to cryo. And I haven't seen any statistics on how much Podman is used. And all the stuff I see from last year's analysis of the usage, Podman wasn't in there at all. So I'm not sure if that's just because it was below 1% or it wasn't an option maybe in the list. But nowadays, when you're running Dockerd, you are running containerd. So Dockerd in the background, if you go and look, Dockerd actually spins up a containerd process for each one of your containers, and then that itself spins up runc, and then that runs your app. So in case you're interested in how containers are run, there's actually a bunch of different smaller services all and running the different parts of it, and Dockerd runs as a single daemon on your host, and it spins up a containerd for each one. Now you could choose to run containerd by itself, and containerd and cryo are the two that are designed to really just be run by Kubernetes. So you don't really need Dockerd there because Kubernetes is doing all the work. And if you want to talk about that stuff, I'm sure Nigel can talk more about that later. But the containerd is technically already there, right? So when I'm doing that Docker bench scanner, it's looking at containerd as well as Docker in there. So you might go ahead and run that. And I don't know if it'll work, actually. I don't know if it'd run on a containerd host, but that's a great question for the Docker bench repo, is to ask, to look around in there if they have a containerd option, because the same people that really work on the open source Docker engine are also the similar set of people that are running and working on the containerd, because they come together when you're running Docker engine. So that's maybe my best answer in terms of I don't know.
Yeah, I think given that they're both sort of spun out of Red Hat, my guess is that there's some ties to SE Linux, right? And I think with Podman, the big deal is like it's running without root privileges. It's running on a single host. There's not a lot. I wouldn't say there's no security concerns, but I mean, it's not really intended to be a big cluster level thing for Podman. Cryo,
Right.
I suspect, has some pretty deep ties to SE Linux. I know, underneath the covers of OpenShift, there's SE Linux is turned on and configured for you and all those kinds of things. So I suspect that there's ties there.
And the trick there is to make sure that, like, if you're running these tools separately, like there's a difference between running all these tools alone and then running them in Kubernetes, because Kubernetes may be spinning up your containers in a different way than if you were to type the commands manually at your command line. So you'll want to look into the differences. Yeah. All right. Let's go to the next one. Although I did see, I think, yeah, someone was asking about the security profile comparison between Docker daemon versus Podman. I don't actually know. I'm a Docker fan, so I'm not smart enough to compare the security profile defaults of all the different runtime tools. For me, I just run Docker daemon when I'm running a standalone machine. If I'm running in the cloud, like I usually run their Kubernetes or their Docker, and those are provided for me. So their Kubernetes usually runs containerd by default. I think all the clouds that I know of, they run containerd underneath, and it's just provided for me. So I just use what they have. So great question though. Let's go back to the slides. All right. This one is maybe not so much of an issue nowadays because a lot of us are getting into orchestration. So we have something else running on top of Docker that does a lot of the work for us, so we don't change the Docker defaults. But this one is the one that gets the headlines with all the scary blog posts about Docker being insecure, which is they're usually not entirely accurate. I'm not into the FUD security scare tactics. So Docker by default does not open any ports when you install it, right? So the TCP socket for Docker is not enabled. You would have to go into the daemon and set up the settings to expose the port. And then ideally, if you were to ever do that, you're going to definitely want to make sure it has certificate authentication, because by default, out of the box, it has no authentication, but it does provide you the ability to give it a certificate, you know, a TLS certificate essentially, and then that would allow it to use certificate authentication there. So nowadays, though, we don't really need that. And so this is more of me educating you on, if you didn't know, we've had a couple of years of this feature where you can use the Docker host environment variable, or even using the Docker command line now with the Docker context command, you can tell it to get to a remote machine that's running somewhere else with Docker using the SSH option like I have here. So if I just typed Docker host SSH with my user and host name, and then typed my Docker command in, it would point my local Docker CLI to that remote engine, and it would tunnel through my SSH connection. So the only thing your tools need, whether it's your admin tools or your CI tools, if they any of them have to talk to a remote Docker machine, they can now do all that through SSH, which is probably something that you're used to in your environment, and you probably have a process for using SSH certs or even TLS certs with SSH, and you can do that in Docker. So let me just show you how easy that is, because it's a feature that's been around and a lot of people still don't know about it. I'm on my local machine, right? And so the way we're going to compare this is we're just going to do a Docker version real quick. And I'm on my local machine with Docker desktop, right? And so let's look at the build time of the server. Now, if you remember back to your Docker education, especially if you got it from me, we talk about the client and the server, and that the client is a different command line binary than the server, right? And so the server is running either locally or remotely, and it's all talking over this HTTP type of interface, whether it's over TCP or a socket or something. And if I look at this build time, let's just remember 129, right? That's the time it was built. So if I simply do that same Docker version command, but then if I back up and I just set Docker host, and this is an environment variable that's been around forever, but it used to only support the TCP protocol. Nowadays it supports SSH. So I can just say, by the way, I have in my SSH config file, I have this set up just for this particular server with my username and which key to use and all that stuff. So I would have set that up previously. And if I just do this, oops, need to put the equal like that. So we're telling it, hey, change the environment variable to Docker version. You will notice that the build time is 124, where their previous build time was 129. So this is kind of showing you that all I have to do is do that, and then I'm tunneling with every Docker command I use. It creates a quick tunnel, does the thing on the local machine, and then returns back to my local machine, right? So it's a super easy way. You can also use the Docker context command to change this stuff permanently. So you, just like with kube control and other things, you can have different settings for different hosts in your machine, and you can switch between them using the Docker context command. That's another way to do it. But this basically rules out any need to ever put a public TCP port on the socket. All right, so let's see if we got any questions on that topic, on the socket.
I don't see anyone. Any questions on that? If anybody has any, feel free to type them into the question panel and we'll get them answered.
Yeah, and that's fine. Most people talk about the socket being, just insecure by default, but the reality is in production, you're going to need things that talk to the Docker socket. You're going to need utilities that are able to talk to the socket, but the way you do that securely is that those things are running in containers on your host with reduced privilege set, but they're bind mounting to the file of the Docker socket, and that's a much more secure way to run system utilities, like if you need to have loggers or monitoring tools, or like what's it called? Portainer. Like Portainer is a really great GUI for running on top of Docker and Swarm and now even Kubernetes. And it has to talk to that socket somehow. So the secure way to do it is locally on each machine using a file socket, so it's not exposed over the network.
There was a question just in the interest of time. So there was one of the questions before talked about or asked about, securing sort of the container itself, sort of securing the image, assuming you got this platform that does all these other things for you underneath the cover. Some steps there. I know, for my own selfish benefit, I'd love to hear about vulnerabilities too. So if we can, get there.
Yeah, so there's a couple of things there, and these slides actually talk all about that. So basically they're all related to the Docker file, right? So if we separate ourselves from the host and we start talking about the Docker file itself, one of the things we do in that Docker file is that we change the user, and we'll see that in a second. The next thing is we can use scanners either during image building, after image building. We can even do that like with Snyk. You kind of get a bunch of different options. You can do it before image building with your source code repo. Then you can do it after the Docker image build. And so you can sort of certify that image. All these things are options with your security tools. And then you also want to focus on your base image and using multistage to even reduce what's going into production versus what you have in CI or on local dev, right? So how do we do all that all at once? Well, I have a single simple little file to show you. It's not even a demo, but I have over on Docker Hub, this is something I just created a couple weeks ago, and I'll warn you, I am not a Java expert, but a lot of people run a lot of Java stuff, especially enterprises that are focused on security. And I have this thing called Pet Clinic. And so if you just go to github.com/BrettFisher/Pet Clinic, this is not my demo. This is actually another common Java, Maven, Spring Boot framework thing that I just sort of copied from them and then created a modern Docker representation of it. So I only created two files, the Docker file and the compose file. Let's just focus on the Docker file because that's really where all this stuff can be done, right? So, and then I don't know how to make links. So we will just jump into the app and we'll find the Docker file at the root of our application. That's typically where people will keep it. And there's a couple of things here, and I've put in tons of documentation for you so that you can go find this and understand what each line is for. But one of the things we're doing here is we're using multistage. This is actually something you'll find on the Snyk blog. I actually found a great post from them years ago talking about the different build stages you can have. And essentially build stages with Docker allow you to basically take multiple Docker files and put them into one, and then copy your app source code, or maybe the jar you built or the binary you built from one to the other, all in a single run. So what this allows me to do is I have one stage up here that pulls in my source code using a full JDK image. This is like a gig, right? This is like a 1.2 gig image, has tons of tools in it, has Maven, has all these different dependency requirements in there for building the app and then testing it. And then I might even have another stage that's just for testing. You'll also notice in this, I run a Snyk test down at the bottom inside my build just to get a report out with their CLI tool to show me, hey, during my build process, before I'm finished image building, what's going on inside of my source code, right? So I could do that here, but this is basically a image stage that's starting from where this first one left off. So the first one is I'm going to copy in just my dependencies. I'll install my dependencies. Then you'll see, and it describes all this in the comments. Then I copy in my source code, and then I do my full build. So I'm creating the jar. And then I'm starting as an optional stage because you can actually target inside each of your builds. You can say, for this image, I want to build all the way through the test stage. And then for another one, you can say, oh, I actually want to build all the way through to production. And the way that I've designed this here, it's a little bit hard to show in a quick demo, but you can see this from line. This from line actually allows me to build for production separately for testing. So from testing. So what this means is that in my CI, I could build and then test for only the master branch, for example, or only for the dev branch. And then maybe once that test is finished, then I'll go ahead and complete the rest of the prod stage optionally, right? So I'm not building maybe my prod quality version images unless everything else passes first. And so down here at the bottom, we'll see a couple of things that are all in those slides. Step one is I'm using a completely fresh, empty, not really empty, but a base image here that has none of my source code yet. And I'm using this JRE, but just the runtime. So this starts out at only 200 meg instead of the 1.2 gig that my development JDK has. And so this has a much smaller number of potential vulnerabilities in the file system. On this case, I'm using a Debian Slim image. So I always advise either you looking at the Debian Slim, which is a pro tip. Like a lot of these things have this great slim image that doesn't have all the building tools. just for running in production. You also might look at Alpine, but Alpine itself has its own set of requirements and testing that you have to do because it's based on a different C compiler and a different set of base tools. So, and Java itself, they actually don't have a stable release of Java with Alpine yet because they're still working on Alpine integration. So anyway, we're starting here. Then we're doing something that a lot of you may not have realized, but most application source code repos, so we're talking Java, Python, Node, PHP, all these things, when you get their images from Hub, they come running as root by default. Now that's not necessarily true of your regular apps like Nginx or MySQL. They all typically have worker processes that will run as non-root users. So that lowers their security profile down so that when your Nginx is receiving connections, it's actually running in a reduced functionality. But for your source code, those source code repos typically come as the root user by default. So you will need to create the user, and this is sort of one of the best practices on how to create that. You'll hard code the ID so that you can rely on a standard user and group ID there. And then we're just calling them Java because this is a Java app. There's nothing special about that name. And then I'm changing this line to use that user. And that means any run command or any CMD after that will automatically run as this reduced user. So you have to be careful. And you'll notice here that when I do a copy, I'm copying my source code from up higher here up at line 21. I'm essentially copying in that jar file that was built in an earlier stage. So I'm not copying in all the source code and all those dependencies. I'm only copying in the jar. And I have to do that as the Java user because since this is going to run as that reduced user that's only a standard user account, I have to make sure that my file has permissions for me to run it. So I'm always going to have to make sure that chown is in there. And then I'm able to run my app down on the bottom in that reduced non-root user in a minimal image, already having had its security scan during the build. I could even scan this image ongoing later on in a registry just by using the same Snyk command with a couple of different options after I've built it. So
Yeah,
there's a lot. There's a lot there, but
yeah. Well, I
got
think
a reference.
at least for me, looking at multistage, so when I first learned about multistage, I focused on the end result, right? Like, great, you get a slim image, you removed everything, and then it sort of dawned on me, like, well, there's these middle stages. You can stop at the middle stage, right? Like, you can set that as your target and stop the build there. And as a developer, right, that may be what you do because all of your tools are still in there. From the Snyk perspective, right? Yes, we can test at all those levels. Obviously, the results you get in the middle, you still have all your tools in there. You may see results that show you that some of those tools have vulnerabilities, but as a developer, those things get stripped out before it goes to production, so I don't have to worry about those. But maybe it's a vulnerability that comes up in one of the open source dependencies. Maybe it's a vulnerability that comes up in Java itself, and so there's some library level things that you'll want to know about early, right? Catch them there. That way, when you get to that final stage in production, somebody doesn't say, "Hey, this thing can't run because we found this serious vulnerability," right? So I think it's good to have all those different steps in there, and I think it's good to sort of it splits up the responsibility as well. And there was
you don't want to always run your tests, right? Like whether it's your audit test or your Snyk test, you don't want to run those on every single image build on your local machine usually, right? So it's nice to have those split out too for that.
Yeah. There was another question that was somewhat similar. Well, there are a couple that were somewhat similar. One is, do you have any recommendations on using open source libraries as part of the containers? I'll pop in there, and then Brett, you can give your opinion, and I think Nigel answered as well. But I think it's absolutely fine. I think most of the time, most of the apps that I see getting built that end up in containers have open source dependencies tied to them, whether it's, in this case, it's Java, it's Node, it's PHP, Python, whatever those, any of those types of things, right? So those very often end up in there in one way, shape, or form, whether it's just because the container itself has Linux components in it or because the apps have dependencies on open source libraries. I think it's extremely common. So, the general observation there would be make sure those things are getting scanned. You kind of mentioned it specifically around Snyk, but in general, right? So Snyk can test those things before they ever get into a container. We can test them straight from the source code repo. And we'll even go as far as opening fix PRs for you and saying, look, here's how you would fix this thing in your dependencies files. There are other ways.
My favorite kind of security, the robots fix it for me.
Yeah, exactly. It's magic. But yeah, and then once it's in the container too, and sometimes you get containers that you don't have the source code for, right? You may have an outsourcer, or you may just have a container that, was developed a while back. It's running somewhere. You have no idea where it came from, but you need to know what's inside of it. And so there are ways like with Snyk, so we can scan the container, we can look for the open source, app vulnerabilities as well as the container stuff. So that's my little plug for Snyk in there, but yeah.
Yeah. I'm looking through those questions. Someone's asking about secrets. I'll give you a quick answer on that because I'm not going to talk about secrets today. In fact, I think we're pretty close to the end of the time. So secrets are typically handled by an orchestrator. So if you're running Kubernetes or Swarm, they have built-in encrypted secret stores that you can use that will store your secrets that can then pass into your containers at runtime. And that's how you would use that. If you're just running a Docker engine, there is no encrypted storage to hold secrets. So you just have to basically put them in as environment variables and hope for the best. Basically, at that point, it's up to you with an external tool like Vault or one of the clouds provided secret APIs or something like that. It's up to you, but you can use the orchestration level for that. You wouldn't obviously do that with Docker files. You probably maybe would set these environment variables in the Docker files to be used and have obviously those secrets wouldn't be stored in your container images. That's a bad practice. It's kind of like storing secrets inside of your repo, right? In your Git repo. So you don't want to do that in your image, but leave it up to the orchestration or up to the cloud provider. My advice.
Yeah, and there was another one too about CVEs. If you find a vulnerability, but the container itself, it's on a specific port or a specific type of application with a well-known port, and that port's not exposed, or you're still exposed to that vulnerability. I think it's a great question. There's a theoretical answer, which is, yeah, I mean, if somebody can get in some other way, then that vulnerability still exists, right? And could potentially take care of it. You may not be exposed via that port. There's also, and again, I'll put in another sort of plug for Snyk. We're also looking at things like how do we prioritize vulnerabilities. So we can do that in one of two ways. One is for all those vulnerabilities, particularly in containers, right? And depending on your base image, like in your multi-stage, that first image you chose, it's a huge image. It's going to have a ton of vulnerabilities in it. I can almost guarantee you. By the time you get to the end, it's slimmed down. But we're going to look at things like which of those vulnerabilities have actual known exploits and be able to direct you that way. So if it has a known exploit, then that's something you want to prioritize and fix, whether that port's exposed or not, probably. The other is looking at how the actual container runs. So which of these things that might be packaged inside your container actually get touched by some of your code? Because if it's just sitting there, sort of dormant, it doesn't mean you don't want to take care of it, but it might mean you don't worry about it as much. It's not the first thing you need to worry about. So those operating system components that are actually being used by your application, or the open source libraries, those sorts of things, those are things you want to make sure are locked in.
Yeah, a conversation that was we were having the other day in the Docker Captain's channel was around the reality that you scan an image when you're building it, but you also need to be scanning these images ongoing because they will get worse over time. So let's say you only update your apps in production once a month, right? Over the course of that month, things will change. And with containers, it's actually much easier to change that base image to a newer version and then rebuild and then deploy to production without necessarily having to change any source code, right? A lot of that could just be a CI process in your CI and CD solutions. But that's something you definitely want to be wary of. If you're someone who's deploying every day to production, it's actually less of an issue because you're building using the fresh dependencies in your tree. But obviously, every one of those dependencies can age over time, and all of this has to be taken into context, like you said, around the level of that vulnerability, whether it's exploitable. Yeah, because I mean, if you start looking at stuff like Debian, I mean, there's 10-year-old open vulnerabilities that just have never been fixed because they're, for whatever reason, there's no known exploit, or it's a very low level, low risk kind of situation. So.
Okay, so I think we'll wrap things up on this part of the presentation here. I know there's loads more to do. We still have some questions. I'll answer a few in the chat window. We are going to take a quick. There's
and again,
plug.
I was going to remind you. The top link is the important part, right? Brett.show/security first. That gets you to the rest of this list. For those of you that wanted to see more of the stuff in that list, we didn't get to talk about user namespaces, but that's something you basically enable inside the Docker engine to run Docker as non-root for the containers themselves. That's all in here, so you can read about that. There's instructions on how to enable it. There's blog posts on it. It's all in there. So
yeah, perfect. So we'll start again in 4 minutes at the top of the hour, so everybody can take a coffee break, soda break, whatever kind of break you need. And then we'll come back and we'll have Nigel on with us to talk about Kubernetes.
All right, Nigel. What is that? I was gonna make a baseball reference, but I'm so bad at sports that I don't even want to mess it up. Yay, sports. Oh, I see you've taken the screen back.
Good job, Brett. Leave Brett's thing up for a bit if you want, while people take the break, and just hand over to me right at the last minute if you want.
Okay. Yeah. Well, we can do either. I've got some transition slides.
It's up to you.
Yep.
The slides are fancier.
Yeah, I think your links are in here too. Oh, we've got your links, and just for everybody that's still listening, in the chat window. So aside from the Q&A window, there's a little chat bubble window, and we have a bunch of links for you there. It's not looping. I'll fix that here in a second. We have a bunch of links for you in the chat window, including all of Brett's links and all of Nigel's links, and then a bunch of Snyk links as well to various resources. So in that little chat bubble, if you click that and expand it, you should have like 9 or 10 or more links to all of these resources as well. So make sure you open those up during the break or open them up before you leave for sure. Make sure this thing will loop. We'll do it again.
Hey, Brett, if you think your slides are less fancy than Jim's, wait until you see how unfancy mine are.
I actually used the template today. I was so excited. It was a white slide with black text, and I reversed it. It was so fancy.
So one of my daughters is currently using my monitor. So I've got pieces of paper here for my prompting, because I'm just on one screen. The old stuff's the best.
Yep. It's it's cool again. Paper and whiteboards are cool again. You can I mean all that like AWS and all these YouTube videos from all these cloud providers, they all have that transparent fancy drawing board where they draw with like different colored neon markers, and it looks like they're drawing on the wall, but you can see through it. I don't know how that stuff works. I have a feeling it's not cheap. Yeah.
I looked into getting one a while ago. It was pretty expensive. I think it was about £7,000, which might be about $10,000. I didn't get one.
Yeah. Yeah, that's
as this is testament to.
Right. How much paper could you buy for that? You could line your house with paper.
Oh, I guess I better pronounce it Snyk, because he said there are some Brits that pronounce it Snyk. I better go a bit of solidarity with my fellow Brits.
Yeah, it's our head of DevRel. I think he does it just to annoy our head of marketing and Gareth. Gareth gets mad at him too.
Yeah.
All right. Okay. I don't want to get on the wrong side of Gareth, so I'll call it Snyk.
Right. Here you go. There were a couple other good questions in here for folks that are listening. Maybe we can go ahead and answer them too. So there was one question like, is it so that the multi-stage Docker file? The question was, is this one Docker file? And yes, it was. It was a multi-stage Docker file. But more to the point, what would be the benefits of having these multiple steps built into a single Docker file instead of splitting them out into, you know, a Docker file per stage.
Multiple Docker files, that was the question?
Yeah, like instead of having that single Docker file that has everything in it versus having, you know, 3 Docker files, one for each stage that you want to.
Basically, at this point, there's no reason to do that. Like once we got multi-stage functionality, all the reasons, and you can look back, like there was one of the challenges with containers is this whole like Docker, Kubernetes, all this stuff is changing so quickly that blog posts that are 3 years old are often wrong or just no longer the ideal thing. So I never use a Docker or any sort of blog post that's over 1 or 2 years old.
They're dangerous.
They are. So what we used to do was people would have multiple Docker files, and then they would build what we called an intermediate image, and then they would use another Docker file to build off of that. And then if they wanted to go into production, they might do something where they, like we called it a squash, where there was varying ways to do it, but one of them was actually to export everything out of the container, then import it all back into a single layer. Basically, all that stuff's gone, and you just use a multi-stage Docker file. It's a complete superset of the functionality of all those different ways. And the nice thing is it allows you to have just one file. And you can, if you go look at my DockerCon, I'll put this into the chat, because it looks like my chat's going to everyone, I think. So
You can send chats.
I have I have a DockerCon 2019 demo with the DockerCon video where I step through a multi-stage setup of a Node.js app. And so I start with a very simple file, then I add more stages to it, then I add more stages to it, then I add more stages to it. And so it does things like testing, scanning, auditing, then production. And so all that stuff's in that repo, including the video. And even if you're not a Node.js person, it's okay, because like 90% of it's really just about Docker and not so much about the application framework or language. You know, the same way, most of the same ways I would build Node.js would be the same ways I deal with any other runtime compiled language, like, you know, PHP or what else? Ruby, stuff like that, right? And where your Javas and your C and your Golang and the ones that create those statically compiled assets or a single file, those are sometimes even easier to use, because to copy into the production stage, you only have to copy that one bundle or that one binary. Anyway.
Yeah, I think it's easier
Brett,
from a management standpoint, right? Like managing 3 files that are somewhere in a source code repo, each one that ends up doing a different thing, right? As opposed to just one Docker file. It's hard enough to kind of keep the Docker file and the image associated with each other anyway. If you have 3 or more, it's all the more.
Well, I remember when multi-stage builds first came, and they were like a godsend. Yeah. I mean, one file with no scripts and intermediate stages and things. So I would pose a question to both you, Brett, and Jim. What could I offer you that would make you go back to the old way of having multiple files? Like, I bet you there's hardly anything I could offer you. You just would never go back to that way. I think, considering how slick it is with, you know, just a single file now, nothing else to worry about.
Yeah,
I don't think you could do it. I don't think you could, because one of the things about the multi-stage is if you the more you spend time in multi-stage and you understand, and then you look into the new build kit, which is related but not the same thing. The build kit is this new builder in Docker. If you just use the Docker command line docker build x, you'll see all this new stuff. Or it's a brand new builder that allows you to do parallel layers, and so you can basically have it to where, and I worked on it with a team the other day, basically about a month ago, on a really large PHP image. And PHP, well, actually, no, I'm sorry, theirs was Ruby, but PHP and Ruby seem to be those languages where they need tons of dependencies, and so you end up with these 1 to 2 gig images, even in production. And so I was working with a Ruby team, and we ended up with like 7 or 8, I think maybe even 9 stages. And the whole reason we were doing it was because their build times were like 15 minutes. And we could take a multi-stage, and I wanted it to do everything, right? I wanted it to do security scanning and NPM audits for NPM dependencies, and I wanted it to do sort of all the minification stuff for their production with JavaScript, and then I wanted it to only have just the bare minimum in production. And since it's a Ruby app, it needed all these node dependencies for building, but it doesn't need that stuff in production. So then I wanted to strip all that stuff out so that it only had the Ruby binary and the bare minimum for starting up, right? And so it took a team a full week of people figuring out what real dependencies do we need from apt, what do we need from Node, what do we need from Ruby, and really none of that was Java or Docker stuff, right? It was all just the team didn't really know their dependencies that well, so we had to go back to their source code and understand what true dependencies do they need in dev versus test versus production, and for testing, in other words, not just test infrastructure, but like actual component and functionality testing. So we broke all that stuff out into stages, and we got this like 200-line Docker file, and it looked complicated, but as long as we put all the documentation in for comments in there, we said this stage only build for this stage if you want to do CI testing in the CI servers, and we really made a nice clean breakdown. We were able to get that build time down to half of their pre-Docker builds, where they were just building it without Docker, because the new Docker build kit stuff allows you to build all those stages in parallel. So it would be building 2 stages side by side using basically 2 different CPU processes, and it was pretty slick. I mean, I don't know how you would ever get me to not do that anymore.
Yeah, I
offer you a lot.
Yeah, I don't think there's any way I would go. I would go back or recommend anybody going back. It does take, it makes the file longer. You could argue it's slightly harder to read, but I think that's just once you figure it out, you won't go back. So a couple other questions that I think will lead into the next section here that I do want to answer. Again, just selfishly, how do you fix vulnerabilities in running containers? That was actually asked by 2 different people. And so again, I'll put in a plug for Snyk here. We actually can plug in, this is kind of why it leads nicely into Nigel's section here. We can actually have a plugin or a monitor that runs in your Kubernetes cluster. So when we detect a new workload being deployed in your cluster or a change to a workload in your cluster, we'll go seek out the containers underlying those pods, and we will scan them, and we'll provide those results to you and tell you, here's what's wrong with it. So we can actually provide the same vulnerability information and fix advice for the containers that are running in the cluster as they're deployed as well. So with that said, that was on Kubernetes. I do want to hand things over to Nigel to go into to his Kubernetes portion of the presentation. You ready, Nigel, to take it away?
Yeah, go for it.
All right.
So I am assuming everybody can see my screen, and I'll crack on.
Not yet.
Was that a yes?
Not quite. Should be. Okay. There you go.
I can see it.
You can. Okay.
Yep, it's to you now.
All right. So, like Kubernetes, I think compared to Docker is hugely more huge and hugely more complex and more diverse, and without being disrespectful, I think more disjointed. So if we wind the clock back and think about when Kubernetes first came, the goals, and I think they're still the main goals today, are just to be frictionless, right? So to speed up deployments, to make it as simple as possible, and just reduce friction. And no disrespect again to anybody that's into security or to the guys at Snyk or anywhere like that. But I do sometimes joke that security is almost like friction as a service or software defined friction. It can cause that many problems. And like, don't get me wrong, security is very, very important. And when you go to real world production environments, you absolutely need to be extremely serious about security. But I do think that, like, if Kubernetes first came to market, or Docker for that matter, and security was right up there as like one of the first things to be developed, I don't think we would be where we are today with either technology, because they would have been too hard to deploy. Now, don't get me wrong, when Docker Inc. started thinking about security in the Docker platform, I took my hat off to them, because I think they did an absolutely fantastic job of making it so simple, and so many out-of-the-box defaults were sensible and really good. But it's a different story with Kubernetes. So we'll see this in some of the examples, right? But security was very much an afterthought with Kubernetes. And when we look at things in a minute in the demos like RBAC and pod security policies and network policies and things like that, even in modern Kubernetes clusters that have these enabled by default, most of the services, like most of the hosted services on Amazon and Azure and Google and places like that, if you enable RBAC, or the, RBAC is enabled by default, since I think 1.8 or something like that. But if you enable pod security policies and things like that, you turn on these security features kind of in the background for you. They turn on workarounds to get around them. And that might seem counterintuitive, but the problem is when you turn some of these technologies on, they're breaking changes. So they will break your existing applications. And also if you're a new user and you've got all of these technologies turned on without some of the back doors opened up to make it a little bit easier for you, then you're just going to have a really, really hard time deploying any applications or getting anywhere with the technologies. So the situation that most people are in is we're deploying Docker and Kubernetes and the horse is bolted, so to speak. We now need to turn on security and start enabling security, but doing so retrospectively is both hard and dangerous. So I think to kick things off, I saw just this week an article from Microsoft here, Threat Matrix for Kubernetes. I'm happy to share this link towards the end, okay? Look, it's all about security, right? So it's not like reading Harry Potter, but I do recommend you have a scan through it because it talks about some of the tactics that hackers take when they want to take control of your system, when they want to elevate privileges, when they want to spread further throughout your system. So I recommend you take a look at the article from Microsoft. Okay, it's got a nice little sort of map here that goes all the way from initial access to the far end of like what kind of exploits they're looking to make with all the stuff that's in the middle. But I've tried to simplify it here on a slide, right, which I hope you can see. So generally the idea, right, is that, and of course, look, it doesn't have to start at a container, but we're focusing on containers in this call here, right? So you start out with a container, somebody gets access to it, somebody malicious, and then from there, they can get access to more containers, or they look for ways to get access to more containers. They want to get access to your host. They want to get access to your cluster. We'll be talking about Kubernetes. And then eventually, potentially, they can get access to your cloud. And if you search the internet for security vulnerabilities within the Docker and the Kubernetes ecosystems, you'll see examples of all of those where somebody can exploit a vulnerability on a single container and can get access to your cloud resources, which is pretty scary. I recommend the Microsoft article for more detail on that, though. So we talk about, yes, we've got applications running already on Kubernetes, and how do we go about retrospectively enabling Kubernetes and finding some of the areas where we are vulnerable. So I'm going to throw out a free plug to Snyk here. So I've just got some free access to Snyk at the moment. Wrong screen there. And I've got it hooked up to one of my GitHub repos, right? And I found when I turned this on, it was actually pretty useful. So this is just a GitHub repo from one of my recent Pluralsight courses, okay? And the course talks about, or it teaches you how to use storage, multi-container pods, and service accounts, right? And anytime, and Brett's probably the same, right? When you're trying to teach somebody something, again, you want to make the experience as frictionless as possible. So if I'm teaching somebody, let's just say about multi-container pods, right? The last thing that I want is to have all of the security features turned on, because it makes it harder for me to teach, and it makes it harder for somebody following along to be able to spin something up and do just that, follow along. So I've got a bunch of YAML files in this repo here where I didn't give a second thought to security. And that will be like a lot of people's test environments and even production environments. So you've already got this stuff out there. How do you then find out, well, what do I need to do to start closing some doors and locking some windows into my environment? So I can see here, just looking at the Snyk dashboard for this particular repo, I can see right at the top here, I've got 5 medium level vulnerabilities and 6 low level. Fortunately, no high vulnerabilities, though those are not my classifications. And you know, getting to some of the things that Brett talked about, right here, I've got a container running as root. Okay, that's a low priority setting. I don't ever set CPU limits or memory limits or anything in a simple lab, right? I have not been explicit about what capabilities that want these containers to use, so I'm not dropping any capabilities there. And another container running as root. And then again, load balancer service is wide open to anybody who wants to connect to it. So I click any of these lines, any of these options over here, and it highlights the lines in my YAML files on the right that I need to go and take a look at, which I thought was moderately decent. But what I really want, and what I think we need more of in the environment, right, is yes, tools like this to highlight our vulnerabilities, but then to take it to the next step and say, well, actually, a fix for that is these few lines of code or YAML or whatever here. And I think especially when we get onto networking, right, and look at network policies, if you have an application deployed to a namespace in a Kubernetes cluster at the moment, and that application, and you're not implementing network policies at all, the ability to turn network policies on, but have an understanding of what kind of traffic to allow is quite a challenge, to be honest. So for security products to be able to run on our Kubernetes clusters, look at our environments and say, all right, you've got a bunch of applications running, I'm just as an example in a namespace, right? They're all talking to each other. You don't have network policies turned on. To turn them on from, let's say, I don't know, a week's worth of observation, you will need all of these ports available between these particular pods. And look, here are some YAML files that you might want to look at deploying. Of course, you wouldn't deploy them straight to production. You would deploy them to like a test or a staging environment first. But for the security tools to be able to look at our environments and make intelligent suggestions for us is something that we absolutely need more of. I know Brett talked about a bunch of stuff on the Docker side of things, and I said before that Docker have done a really good job of implementing security simple. We are not at that kind of state in the Kubernetes world at the moment. In fact, I find, well, this is true actually of some of the Docker technologies like AppArmor and SE Linux and dropping capabilities and things. They can be prohibitively complex. But I think in the Kubernetes space, too many are still prohibitively complex. So anyway, I want to move the conversation along a little bit.
Yeah, quick
for it.
Thing, Nigel. There's something blocking part of your window, like on the right side. I don't know if you've got another screen open and GoToWebinar is hiding it, or.
Yeah, GoToWebinar is hiding it. Ooh, I do not want to leave the webinar. So the problem I have here, see if I can fix this, is that I am just on one screen. So I'm going to just park this as far to the bottom as possible.
There's a little arrow you should be able to find. There's a little red arrow that might shrink the interface.
That looks better.
Yeah.
Brett. Is that better?
Yeah, except for it's a black screen.
Epic. All right. Okay, so I want to talk briefly, and we'll look at some demos about role-based access control, pod security policies, and also network policies. But to start the conversation off, I think we need to understand at least how objects are admitted onto a Kubernetes cluster. Okay, so looking at the diagram right now, from you taking an application, let's call it a pod that you wish to deploy to the cluster. Make sure I'm on here. Okay, so we take a YAML file and we use the kubectl command line utility, generally speaking, to post that to the API server on Kubernetes. Okay. Once that hits the API server, it goes through a process of authentication. So I think if we look at what I'm trying to represent as the object down in the bottom left-hand corner, we are deploying a deployment into the ACG namespace, and it's me or a subject or a user called Nigel that's trying to make that deployment. So the authentication phase, generally speaking, we'll use certificates, but there are other ways to authenticate yourself. We'll say, okay, I've got a request coming in to deploy an application from somebody called Nigel. Let's actually make sure that this is Nigel. Once we've validated that, we move to the next step, which is authorization. Kubernetes has a pluggable authorization layer. generally speaking, we will use RBAC. It's enabled on most Kubernetes clusters now. And the job of authorization is to say, yes, we know that this is Nigel who's making the request now, but is Nigel actually allowed to perform the action he's trying to perform? Let's say I'm trying to deploy a pod into the ACG namespace or a deployment here. Am I allowed to do that? Assuming that I am, I will pass authentication and authorization and move on to the next phase, which is admission control. I'm saying this because if we have time, we're going to look at a particular admission controller called the pod security policy, which allows us to apply default things to all pods that are being created on our cluster or block them if they don't comply to the policy. So an example would be, and Brett talked about this as well, privileged containers. So a privileged container effectively is a dangerous container, as it can have almost root access to the host that it's running on. So we can configure an admission controller that says we are not going to allow onto our cluster any containers that run as privileged containers or in privileged mode. And we would do that via something called a pod security policy. Once we go through that, so we've authenticated, we've authorized, we've applied some policies, we've maybe rejected the container. If we haven't, if it passes the policy inspection, then it just goes on to have some basic schema validation. So I want you to keep that in mind, and we'll come back to it shortly. Now, from an RBAC perspective, okay, so I have a, which window is it? Okay, so I have Docker desktop running on my machine. So a single node Kubernetes cluster running Kubernetes 1.16. We're going to have a quick look here at implementing role-based access control so that one of the dangers of any pod that is deployed to your Kubernetes cluster is, generally speaking, out of the box, it will have a service account associated with it. And that service account gives it broad permissions on your cluster. So if that pod or the container running in the pod is hijacked by somebody, that service account potentially gives them the ability to locate other objects in your cluster, other pods, services, deployments, potentially secrets, things like that. So by default, a container deployed to Kubernetes gets a service account that allows it to query the API server and basically learn a ton about your cluster, and we don't want that, okay? So I have got, I think I'm talking probably a bit too much here, but I have got a file called rbac.yaml here, which says, okay, I am going to give permission, just the sole permission to list services in a cluster to, so this is permission to list services up here, and I'm going to assign that to a service account called service reader, okay? So if I flip back to my cluster, and if we just kubectl apply f rbac, so we will apply that role-based access control rule to our cluster, and we will kubectl, can't type, create a service account called service reader. So that service reader, thank you to the RBAC rules, is now able to list services in our cluster. So I also have a pod, which is called pod 2. So I have a pod here which mounts or which uses that service account that we've just created. It's got curl installed in one container, and it has another container which is exposing the Kubernetes API. So if we deploy that to our cluster, kubectl apply f, it's called pod2.yaml. I apply that pod, whoops. Did I not call it the right name? Type. Okay, so I have a pod created, and if I exec onto that, kubectl exec IT, and I believe it's called SA demo, yeah. Now then, hope it has curl installed, which it does. Okay, so this pod, or the container running in this pod, should only be able to list services in our cluster. So if I curl localhost on port 8001, that's just the Kubernetes API is exposed on that port via the other container in this pod. API v1, I should have had this saved really, shouldn't I? Namespaces, I'm bound to get a typo in here. Okay, no typo, that's an amazing. And basically, we are able to list service objects, right? This is the Kubernetes service in the default namespace, which exposes the API. But if I was to change that and say, I now want to list pods, let me tell you what's going on here. So I talked before, and by the way, I was able to list pods and I shouldn't have been there. When I talked about enabling role-based access control on your clusters and then people enabling backdoors, one of the things that Docker Desktop does is it basically implements a backdoor that gives every service account admin on the cluster, kind of negating the whole reason for having role-based access control. And the idea is just so that it's enabled, but it's not going to break anything that's already running. Anyway, so Docker Desktop runs a cluster role. This is the hardest word in the English language to type. It's not even in the English language. Cluster role bindings. It has a cluster role binding called Docker for desktop binding. So if I delete that, kubectl delete cluster role binding. Gosh. Oh, please do me a favor. This is the thing when you flip between using Linux and PowerShell and what have you, right-clicking doesn't always do the same thing. Okay, so we've deleted that cluster role binding now. So if we jump back onto that pod, and if we try and curl the pods now, see we get forbidden. So what I've done there is I've disabled the backdoor that Docker Desktop enables by default. So we are running role-based access control. If this particular pod or container is now compromised, the service account that it is using does not any longer have broad access to the Kubernetes API. So if this is, if we were to flip back to this slide, I don't need to open it up, right? But to find more containers from this container, or to, to locate more pods, to just generally learn more about your Kubernetes cluster is automatically a lot harder now. So that's kind of dipping into role-based access control. I think it's been enabled in Kubernetes since about 1.8, but it's been backdoored in Kubernetes since about 1.8 as well. So although you may think that you have role-based access control turned on in your cluster, the flag might be there in the API server to have it turned on, you must check your environment for backdoors. Like there's a backdoor there in Docker Desktop. Most of the hosted cloud providers or the hosted Kubernetes services on the different cloud providers also have backdoors. So just thinking it's turned on is not, well, it is turned on, but it's not always effective. I want to flip and talk about pod security policies for a second. Yeah, so this touches on, yeah, go for it.
Real quick, yeah, one question came in, and if you want to take a quick run at it, and it relates to that, like, because you just mentioned service providers, so I figured I'd jump in here. For people that are using, some sort of managed Kubernetes service, right? This is very similar to what we had with the Docker question earlier. Is there anything they can do to ensure that, their EKS clusters, AKS clusters, GKE clusters, whatever that might be, right? OpenShift on top of something, right? That those are secure, or do you, you don't have access to them?
I think, like, very similar to what Brett said before, you are making a conscious decision anytime you decide to use a hosted service. Excuse me, and that conscious decision is you are outsourcing a bunch of stuff to your cloud provider or to your service provider, and you have to have an element of trust there, okay? I do think that they're pretty good. Most of the hosted Kubernetes services out there, right? They're very good at making it easy to spin up Kubernetes that is moderately secure and is pretty highly available. They're pretty good on the high availability front and on like the performance front, but it's not in their business to make it hard for people to use. So most of them have huge backdoors that circumvent things like pod security policies, things like role-based access control. And your only real options there are to fully understand the platform that you are working on, and to figure out what those backdoors are, because most of them you can turn off by disabling certain cluster role bindings like I did there, or disabling certain pod security policies that allow or maybe not as tightly locked, because the way pod security policies work, if I remember right, is that as soon as Kubernetes finds a policy that will allow your pod, it will spin the pod up. So if your cloud platform has created a default security policy for all namespaces maybe, and that's wide open, you can always then go and turn that off. So there are some things that you can do, but then of course you absolutely then focus on the things that are in your control, like hardening your images, making them as small as possible, regularly scanning them. I think I answered in one of the questions, and Brett touched on it as well, making sure that it's not just a one-time scan and hey, we're good now. Keep scanning them. So there still is a bunch of stuff that is within your remit, but you have handed over to your cloud provider control of a bunch of the stuff there.
Yeah, I think my own past experience, I worked for sort of a blip on the radar cloud provider, but it was a public cloud nonetheless. And I have lots of folks that I know that work at like AWS and Google and things now too. And one of the things I know that they do fret over is security. If there's a huge breach on one of those public clouds, right, it's going to affect every single customer that they talk to for the next 3 years. So it is a huge concern. That doesn't mean they do everything exactly right or that it's all well documented. So I think to your point, you should know what decisions they've made. You should chat about those decisions with your, with your service team. Make sure you understand why those are there, what holes are they open, and why are those holes open. You always have the option of rolling your own. If you want to control it, you can roll your own. That comes with its own set of complexities, though, right? So
it does, yeah. So, well, the next demo that I'm going to do here with pod security policies, I've effectively rolled a couple of my own clusters on AWS, just because a bunch of the backdoors and things that all the different cloud providers that I'm familiar with just made it so hard to demonstrate this, because I would enable a policy that would block, for instance, privileged containers, but they would have so many backdoors that were open. So I'll finish my answer to that question by saying that, yes, while you are consciously outsourcing some of the control to your cloud provider or your hosted service provider, in no way does that mean that you don't have to think about it anymore. The responsibility is still, of course, with you to understand how they have done things and then make sure it's as secure as possible for you. Yeah. So I just want to quickly, actually, on the, I think the Kubernetes website I've got open here, pod security policies. So we talked before about authentication authorization and then admission control. And pod security policy is an admission controller, probably the most important one or most used one from a security perspective, okay? And if you can see, this is just from the Kubernetes documentation site, right? Running privileged containers, we can control that and block that, okay? Use of host namespaces, use of host networking using host volumes, host path volumes and stuff as well. This is a list of things that a pod security policy will allow you to control. We will look at blocking privileged containers in a quick example here, right? So I have a couple of clusters going here in AWS that I've built myself, which gets you the purer experience, if you will. First of all, I'm going to be on a cluster called Snyk, which has currently, if we can see, kubectl get PSP, should have no pod security policies, which it does not, okay? And I also want to confirm that if we get all pods, okay, this is the pod that's running the API server here, right? And if we take a quick look at it, specify namespace. Okay, so this is effectively the API server running as a pod, of course. And this is the list of admission controller plugins that are enabled. Don't really want you to look through them all. There's about 10 there, but pod security policy is not currently enabled. Right now, I was going to show you how to enable it. Well, actually, I will do that. I'll show you how to enable it here, but I do have another cluster that already has it enabled, just because when I do enable it in this cluster, it then takes about 5 minutes to do the reconfigure and bring up the new configuration. So COPS, I'm just going to bring my cursor up here, right? So COPS allows you to edit a cluster. And within this cluster, I can say, got it somewhere here. Now, where are we? Get this list of API server flags. This is effectively, I just added always pull images before the call, so I've obviously got some weird tabbing going on there. So this is a list of admission controllers that I want enabled on my cluster, okay? Front and center is pod security policy, all right? So if I save that, then I would do a COPS update cluster. Now it may want me to give the name of the cluster here. No, it's all right. Okay, and then if I do -- yes to apply those changes to my cluster, this is effectively changing the configuration of the API server to enable the pod security policy admission controller. I need to do, I'm pretty sure I'll need to, I'll need to do a proper rolling update in my cluster. Yes, so the master here needs to be updated, which is just a yes command like that, and that goes off in the background and will update my cluster. However, it takes about 5 minutes, so I've got a different cluster. Let me just flip to that cluster, and by switching my kubectl config, so and I will go kubectl config, use context, this one here, which I created earlier. So if I now do a kubectl get PSP, there are no policies enabled in this cluster. But if I'm just going to need to get the name of the API server container in this cluster. So get pods. It's obviously got a different name in this cluster. And if I kubectl describe pods, so up here, we should see pod security policy is enabled on this particular cluster. Now, interestingly, right, so, and this is one of the dangers, right, of enabling something like this, and why the cloud providers and Docker Desktop and people like that put in these backdoors, right? By enabling that without configuring any policies, just enabling the controller will stop any pods being created. So we'll just see this here. I have got an unprivileged pod here in this YAML file. So if I go kubectl apply, okay, I am not allowed to deploy that pod because no providers or no policies are available to validate the request. So simply by turning on pod security policies without enabling any policies that allow you to deploy a pod will stop all pods being deployed. Which is obviously scary for anybody, including a cloud provider. Let's say they were to push a new version of their cluster, enable pod security policies. If you don't have any policies created, the admission controller on its own will stop you creating new pods. We don't want that. So I have a pod security policy pre-created here. We don't need to look at it all, right? But basically, pod security policies are full-blown API objects in the Kubernetes API, calling this one Snyk PSP, and we're saying, are we going to allow privileged containers? By saying false means we are not. I have a copy of that here locally. So if we kubectl apply this PSP. Whoops. So we now have, might have been better if I just typed it. Yeah, so we now have a policy running in our cluster that has the pod security policy controller running effectively. So now we've seen from this here that we will not allow privileged containers. So unprivileged containers should be allowed. So if I try and start that unprivileged pod again, this time it gets created on the cluster. Okay. However, I have a pod here. All we really need to care about is in the container spec section of the pod manifest that I have security context privilege equals true. So this will try and run as a privileged container. So if I come back here and say the name of the file is podpriv, I am not allowed to deploy a privileged container. If we look closely, it's a different error message from before. We can see here, true privileged containers are not allowed. So I've gone through that a little bit quick. I just want to recap, right? The whole idea of, so Kubernetes has a bunch of good things to help us lock down our clusters and our containers. Some of them are prohibitively hard. I think we certainly need more tooling to come along that makes life simpler. But Kubernetes has a bunch of stuff already created, role-based access control, network policies. I'll ask Jim, I'm not sure that we're going to have time to look at those. Pod security policies, all of these things that do give us kind of fine-grained control over our clusters, but turning them on requires, I don't want to say expertise, but you don't want to turn them on. Well, like I showed there with the pod security policy, right? Just turning on the admission controller, you might pat yourself on the back and think, okay, I've done a good thing there. But if you don't understand what you're doing, and if you haven't got policies already created and in place, you're probably going to end up in a world of hurt. So, look, I'm not a Kubernetes expert, a Kubernetes security expert. I'm not a Kubernetes expert either, but I'm not a Kubernetes security expert. And I would go so far as to say that Kubernetes security experts are very few and far between, and we need a lot more of them. So kind of on a bit of a tangent, if you're looking to get into Kubernetes and you've got a bit of a security background and a bit of ops and a bit of dev, you could do worse than making a name for yourself as a Kubernetes security expert. Now, I do have demos and stuff on network policies, Jim, but I don't know if we have any questions or if you want to wade in on what the timing is looking like at the moment.
Yeah, we've got a few minutes. I do want to put in one more shameless plug for Snyk. So you showed early the ability to scan the deployment YAML and detect certain things that could be as part of your deployment. We also have, as part of that same feature, the ability to scan your PSP YAML. So that file that you just had there, we can also scan it as well, and we'll detect very similar things, right? Like you should set this so that people can't run privileged pods in your cluster, right? That would be something you should have in your PSP file. So that's another thing that we can detect in there. There was one question that came up, and I don't know, maybe it got deleted. I'm not sure where it went, but anyway, the question was, and this sort of ties into becoming a security expert, I think, overall. Do you recommend people get their CK, the certified Kubernetes administrator? I don't even know if there is one for security specifically. Is that, but
yeah, so I don't know if there is one for security actually, but I recommend, look, I don't want to upset anybody when I say this, right? I used to be, when I say a hiring manager in a previous job, like I was a techie guy, but I've had roles where I've also been responsible for hiring people into the teams that I looked after. And as an individual, okay, I always prized experience over having a certification. However, having experience and a certification is almost a perfect match. And I will say as well that at the last company that I worked at, where I had responsibility for hiring, the HR department within that company I mean, they would get a stack of resumes, right, for every job that we'd advertise. And if people didn't have a particular certification, they would just bin those resumes, right? So, so yes, get your certifications. I think certainly of the certifications that are out there, the CKA and the CKAD certifications are valuable, but they're also kind of fun as well. They're not just like multiple choice questions like we used to have with, I don't know if you ever took an MCSE or anything like that. You know, it's proper hands-on, and if you like that kind of stuff, kind of fun to take as well. So don't expect it to be the be all and end all, and don't expect it to land you the best job in the world. But I don't think you will go wrong by taking those certifications. They're challenging, which is always fun, I think. And put it against your name. Why not? Yeah, definitely go for it.
Yeah, good. I don't think there were other questions. Maybe there was. Wait, let's see. Oh, yeah, there was another certification question, so we got that one. There was one question though, and this maybe it leads into the next thing you were just talking about, but maybe it's more general, right? So you talk about pod security policies, don't let these things run, but how do some pods need privileged access, right? Like CNI pods, for instance. How do you handle those separately? Like I don't know if that's via pod security policies or if it's another.
Yeah, I mean, so you can run multiple pod security policies in your environment with different settings. You can slice and dice your cluster by namespaces as well, like so deploying different policies against different namespaces. They are namespaced objects at the end of the day. I think that actually I want to mention that as well. So just I'm pulling it off to a tangent. Maybe bring me back to the original question if I don't, Jim.
Mm-hmm.
But when you've got all this stuff out there already, right, just turning something on is like it's a scary thing, and it is a legitimately dangerous thing to do. So what I would recommend to people is that you may want to look at taking an application that is maybe net new or something like that and deploying it into a new namespace. And within that namespace, having your tighter controls, running your pod security policies and things like that. Of course, you would want the same setup in like a staging environment first, all right? But rather than taking like a namespace that might have 20 apps already in that are line of business, you know, critical production apps, don't start there, please. Take something new, spin up a new namespace, and deploy a first app into there with your new policies. And then as you gain more experience, add more applications to that namespace, or replicate that kind of security stance that namespace has within other namespaces for other applications, and then come back and look at your older applications. Never bite off the important stuff and the hard stuff first, of course. So yeah, I mean, I guess the recommendation would be use namespaces, which we say all the time, right, are not workload isolation boundaries, all right, but they are very good ways of having multiple namespaces with multiple different security postures in each.
Yeah, I think that answers. I think there's an interesting combination of RBAC, namespaces, pod security policies, and probably several other things, right, that interplay with each other. And they can be selective, right? So the pod security policies can apply to certain roles and roles to certain namespaces and all those kinds of things, right? So there's a bit of an interplay there, but you can also be selective. I mean, so certain things that need to run privileged, right? You may have a very small subset of users that can do anything with that and sort of get around, you know.
Yeah, I can't say enough though. Running containers as privileged is like, I don't know, you're really asking for trouble.
Yeah. Most of the time, your Kubernetes cluster, whatever you're choosing, is going to have, it's already got a CNI plugin. If you want to switch it out, you can. Yeah. Generally speaking, the CNI provider is going to tell you exactly how to do that. And if they can't tell you how to do that for the chosen Kubernetes distribution that you're using or service that you're using, then maybe you want to stay away from that combination of things.
Yeah.
Yeah.
Jim, do I have time to go through some network policy?
Yep. Yes. Yeah, go for it.
Okay. It's always an interesting mix of rushing it and people being like, yeah, I didn't get anything from that, thanks, versus running over time. Anyway, So I am on a different cluster now, which is on GKE, and I've currently got 3 pods running. Okay, it doesn't really matter what they are. We'll look at how I've labeled them in a second, because at the moment, if I do a kubectl get network poly, whoops, I'm sure there's a shortcode for this one actually. Okay, so I do have policies running at the moment. This must be from an earlier test. So I'm just going to delete them. Oh. So the idea is here, I want to start from a cluster that doesn't have any network policies enabled, okay? And if we can see I've got 3 containers running up at the top here, right? So if I think kubectl exec onto netpod 1. Oh, do you know what? I'll tell you what I want to do first. I want to get the IP addresses of each of my pods, right? So right, okay. Now if I exec onto pod 1, so out of the box, right, just about every Kubernetes cluster that you will get anywhere does not have network policies in place. And without them being in place, we've got this lovely flat, generally speaking, overlay network that all pods connect to. And it's great from a usability and a let's have no friction perspective, but it does make your network wide open, which if somebody gets onto one of your containers, you don't want things to be wide open from any perspective, especially from the network perspective. Okay, please tell me I've got ping installed. Oh, great, okay. Just give me a quick second here to, right, so apt-get install. Now I know it's not going to be called ping, but it should give me the package, which it does. Lovely. So I'm just installing ping here on this particular container. And I'm going to have lost the IP addresses that I want, but I'll scroll back up. So ping, yeah, good. Okay, so I just want to demonstrate that I can ping. I'm on netpod 1 at the moment, so I should be able to ping either of these containers. Ping. Oh, dear me. I've switched back to PowerShell, haven't I? Doesn't quite work the same as Linux. There we go. So yes, I can ping pod 2, and I think this was .6 was pod 3. So network is wide open at the moment. Like I say, great for usability, not so great if you get owned by somebody. So again, if you were in production and you were to take an approach where I want to start applying network policies to my Kubernetes clusters, as I mentioned before, don't go and apply them to your business critical apps running in whatever namespaces they're running in, okay? Spin up a new namespace and take a steady as she goes approach, all right? So one way, I should have a couple of files in here. Oh, I'm in the pod, aren't I? Okay. So I've got a couple of network policies here. I'm just going to show you them. We won't spend time looking into the detail, right? But I have a default deny all policy, right? So we would have a new namespace. And if we were to say, right, we're going to start deploying applications to this namespace and we want to apply network policies here, good place to start is saying, right, because any pod or container that does not have a policy applied to it is able to talk to anything, the good practice is to say, I'll tell you what, we will create a default deny all policy for that particular namespace. It basically selects on every container or every pod that gets deployed into that namespace and says, you can't talk to anybody. This is kind of what it looks like, right? Detail, all right? So I'm going to apply that. So kubectl apply, I think I called it deny, yeah. So if I now jump onto, in fact, I'm going to do this in a different window. It's why I had so many windows open. If I exec onto that contour, oops. I'm going to take this command and run it in a different window. I'm going to ping. That doesn't really matter which one. Okay, I'm getting nothing now, okay? We've applied that default denial policy to this namespace. Now, that's kind of all well and good, all right? But we do want things to be able to talk to each other. So I have another policy in there that will allow, again, this is detail, right? We don't have to talk about it right now. But it's basically saying ingress and egress. So incoming traffic, don't think that's not ingress as in from the internet, right? It's traffic coming into the pod, and egress is traffic going out of the pod. On any pod that has this particular label, we are going to allow traffic going out and traffic coming in. Now, this is how I built the 3 pods that we've got in that namespace. 2 of the pods have the label as true, we can see. One of them, well, it could have just not had the label, but I decided to give it the label but call it false. Doesn't really matter. So 2 of the containers, once I apply this new policy, will be able to ping each other, and 2 of them won't. So which screen do I want? I want this. No, I want this one. Right. So if we now apply, oh God, man, Nigel, what did I call it? Allow ping. Yeah. So we now have kubectl get network policy. We now have 2 policies in force on the network. And obviously, I was kind of hoping that would start working, but it's not, because that particular pod, or that particular container, pod, does not have the allow ping label. So I can ping the 1.5 container, but I cannot ping the 1.6 container, which, if I just bring it really quickly back to here, this is the container that I cannot ping. Okay, it has this label. This is the container that I can ping because it has the label that the network policy is selecting on. Yeah. So again, if I was just to say the primitives are there from a Kubernetes perspective, we've talked about RBAC, I'll call it a primitive, and pod security policies, network policies. There's all right. We can force the container runtime to always pull images instead of using locally cached images, because that can be dangerous. We can tell them and force them which container registries they're allowed to pull from. All kinds of different things are possible. It just takes kind of effort and learning to get the confidence to be able to do it, but then also having sort of the right plan of attack of going about this. Now, I will say, I touched at this at the beginning. I'm just going to wrap up on this, Jim, if you're worried about time, is that we need the tools, and I'll include Snyk in this as well. We need the tools, especially, I think, from a network perspective, because networking is so core, but it's so complex as well. We need the tools to be able to watch our network and come up with recommendations for us, because us being able to, go through our YAML files, which are long and many, to get all the different teams to talk to each other, all the different application owners to say what network traffic do you need enabled and stuff, you're always going to miss something. So do that, but then also have the tools that are watching it to say, these are the ports that we need open. This is the traffic that you need for your applications to run. And here's some network policy YAML files that you might want to test with your applications. And then, of course, as always, not just in production, but just in the world in general, test, and do more testing, because if you don't, you're going to get bitten. So, Jim, I'm effectively done. I'm happy to answer questions. I'm just looking at the battery power on my laptop. I might have to flip onto my oh no, I'm all right, I think. I might have to flip onto my internal webcam at the moment, because this one is stealing my power port.
Okay. I think the screens are flipping over. Yeah, so which is fine, perfect and great. And we are getting right up to the top of the hour. So I do appreciate everybody's time. We had tons of great questions come in. There's a few we didn't get to. I apologize for that. I'll write up a blog to follow this, and we'll have that on Snyk, and we'll answer some questions that we didn't have time to get to, as well as the other questions that came up. This presentation, for those who asked, we will have a replay available so you can come and watch this, at your leisure, or pass it on to other folks as well. Do want to give again a shout out. Next week is DockerCon. Both Brett and Nigel, pretty much all the Docker captains will be there, I think. And there's a special track all day that you can go and chat with them and get more info on containers and Docker and what's happening there, as well as several other great presentations. If you want to see more on Snyk, I've got a presentation there. I'll show you exactly how that works and give you sort of a systematic approach specific to vulnerabilities. You can sign up for Snyk for free, so you can start using Snyk for free. You don't have to pay us anything to do that. Go to snyk.io, and it'll walk you through essentially how do we scan your open source dependencies and how do we scan containers for vulnerabilities and Kubernetes YAML files and things like that. So again, that's something that anybody can do. So I would encourage you and happily help you do that if that's something you want to do. But again, Brett, Nigel, I appreciate you joining us today. Appreciate our audience for sticking around for 2 hours, and that will wrap things up. Thanks, everybody.
Yeah, thank you.
Cheers.